Welcome to Thinking Aloud. I'm not Marcus Smith. I'm just playing him on radio for today. Our guest is Gillen D'Arcy Wood, who's professor of English at the University of Illinois Urbana, Champaign. He's the author of several books and articles. Among these books, The Shock of the Real, Romanticism and Visual Culture, 1760-1860, and published in 2001. Romanticism and Music Culture in Britain, 1770 to 1840, published in 2010, and the book about which we'll be talking with him today called Tambora, The Eruption That Changed the World, published last year from Princeton University Press. He's in town for a symposium on the future of the environmental humanities being held here at BYU and at the University of Utah. And he's also the guest of BYU's Romantic and Victorian Research Group sponsored by our Humanities Center. Welcome, Gillen, to BYU.
Well, it's a pleasure to be here. Thanks, Matt.
It's great to have you here. I've got to ask you about the inspiration behind your latest book. The book you wrote before that, the one on romanticism and music culture in Britain, you mentioned in the preface there that you were a musician as a youth, and you thought you might have professional aspirations. So now you moved from a book on music to a book on violent weather patterns. So did you have sort of aspirations to be a meteorologist as a child?
No, nothing like that. I was the world's worst science student, as a matter of fact. Completely lazy and uncurious, and have come to a great interest in science later in life. There are a couple of light bulb moments for me, I think. One having to do with climate change and a turn in my interests toward looking at antecedents to the climate predicament that we face in the 21st century, and thinking how could I turn the training that I do have in 19th century history and culture to contributing to ongoing research into climate change and human adaptability to an environmental crisis that is global. And toward that end, I managed to acquire a fellowship in studying in a second discipline at the University of Illinois, and I spent a semester sitting in atmospheric science classes. And in one of them, one lecture was on volcanology and the relationship between volcanism and climate. And true to form, it was a subject about which I knew nothing. And the name Tambora came up again and again in the course of the professor's lecture on the subject. And here it was, this massive eruption, probably the greatest in the last 10,000 years on planet Earth, 1815. And I didn't even know, I barely knew the name, I thought perhaps it was in Sicily. I had no idea about it at all. And the Greeks say that, good things come from shame. In fact, often only good things come only from feelings of shame. They motivate us toward behaving better and producing good works. And certainly it was a wave of shame that overcame me in the course of the lecture, thinking this is a central geological event in the middle of a period that I've been studying for 15 or 20 years and have built my career upon, and yet I know nothing about it. And I knew immediately that the only proper penance that I could serve for my ignorance was to spend 5 or 6 years researching this topic and writing the book, which didn't yet exist, on the global consequences of this massive geological event 2 centuries ago.
Well, it's a great book. It's a great read. And it's interesting about it, it's both the book for academics and for an educated, non-specialized readership. I mean, it tells a very compelling story. It's surprising that there wasn't a book about this. It surprised me when I read it because of the picture you set forth of the massive effects this volcano had for many years afterwards, this eruption had. Just how big was this? You said the biggest in the last 10,000 years. People might know about Krakatoa, for example, late 19th century eruption. How big was this eruption, and where is Tambora?
Well, Tambora is located on the Pacific Ring of Fire, so-called. So a whole chain of volcanoes that run through Indonesia and Southeast Asia. It's not far from Krakatoa. It's not far from the islands of Java and Bali. And it's relative to Krakatoa. See, this is the question that I would continually face is, so you're the one writing on Krakatoa because it is the iconic 19th century Southeast Asian volcano. And I would have to correct them and say, no, I'm actually writing on a volcano that was 3 or 4 times the size. And there would be a look of astonishment, and I would follow up with explaining why it was that Krakatoa benefited from the revolution in global communications in the mid-19th century, where you have the telegraph and the steamship. So news of Krakatoa's eruption was able to spread around the globe within a day, whereas Tambora in 1815, before the telegraph, and of course in the midst of the Napoleonic Wars, or the conclusion of the Napoleonic Wars, was really happening on the periphery of Western global consciousness. And there was no means of communicating the disaster. And even so, there was no link between the disaster that engulfed the area that was then the Dutch East Indies and the cataclysmic extreme weather events that unfolded globally in the 3 years following. There was no scientific means for people in Europe or North America to make, or anywhere else, to make the connection between the volcanic event and the climate deterioration that followed. That would have to wait until the latter part of the 20th century. Right. So, the book couldn't, you asked why hasn't the book been written? There is a lag or a discontinuity between the historical archive, the fragmented historical archive surrounding the eruption of Krakatoa, the bad weather across the globe, and then the scientific literature that comes, say, from 1950 onwards, which enables us to connect the dots between the eruption and the various weather events around the world that followed in the aftermath.
I want to get to these weather events because you really tell a very interesting story about things that happened as far away as India and the United States and in China, and not just around the islands of the East Indies or today Indonesia. How was it that Tambora was able to create these weather events? You talk about both the size of the eruption, but also the location of the volcano. You say this wouldn't have happened had it been, say, in Iceland.
Correct.
Why is that?
Yeah, the physics of volcanic eruptions and their impact on global weather depends on their latitude. So North Atlantic volcanoes, their erupted volcanic matter into the atmosphere does not enter the global circulation system. So a volcano needs to be somewhere near the equator. And Tambora is located at 6 degrees south of the equator, so perfectly positioned. It also erupted its magma sufficiently beyond the atmosphere, actually 40 kilometres up into the stratosphere. So height is an incredibly important factor. People often ask me about Mount St. Helens and say, well, it's St. Helens, clearly something comparable, but not really. A much smaller eruption. And also that eruption blew out the side of the mountain. And so its impact on climate was nil. So there has to be a certain height attained whereby the aerosols from the volcano can escape the world's the global weather system, not be precipitated out via rain, and therefore form a kind of screen, volcanic dust veil up in the stratosphere that then blocks the sunlight and forms a kind of radiative barrier and cooling the globe.
Okay, and that global cooling, and this is really interesting. I wonder if you could talk about a couple places. So, for example, it had effects on India and China. Let's talk. I want to get to the Arctic in a minute, because there's a great chapter in your book about the Arctic, and there's a great one about the United States and about Ireland. Quickly, what happened in India? What happened in China as a function of this massive eruption?
Okay, so the India chapter, the India example is a particularly interesting one, and again could not have been written without very recent developments in epidemiological research on the relationship between climate and disease ecology, in this case cholera. So the first link in the chain of causation between Tambora's eruption and epidemical cholera in India is the depression of the Indian monsoon in the years following the eruption, so in 1816 and 1817. The Indian monsoon is the largest, most dynamic weather system in the world. It contains more energy than any other, and because it depends on a thermal differentiation between land and sea, that the physical fact that heat in the atmosphere warms the land more quickly than it warms water in the Bay of Bengal and in the Indian Ocean. Now, if you have a context of global cooling, a thermal deficit, then that differentiation between the heat of the land and sea is reduced, and therefore the energy is reduced in the entire monsoonal system. So in 1816 and 17, you have a decrepit monsoon, a vastly diminished monsoon, and delayed rains. So you have crop failure in the first instance, and drought that follow, and once the monsoon belatedly churns back to life, you have it's the opposite forms of extreme weather. You have 100-year floods. And both these conditions, extreme drought followed by flood events, turns out to be especially conducive toward the production of the cholera microbe, or the production and reproduction of cholera microbe, and its change of state, so variations in the cholera microbe. And this is what happened in 1816 in the Bay of Bengal, which is where cholera has been endemic for time immemorial. Now, what happened in 1816 was that you had these extreme weather events and the depressed monsoon causing a kind of new chapter in the global life of the cholera. It changes shape, it enters into the waterways of the human community in the Bay of Bengal, and instead of being merely another endemic episode in the history of the cholera in that community, because it has changed its state, it now finds a host of fresh victims. So an endemic disease, right, cholera, suddenly takes on epidemical proportions, right, and potentialities, and that potential is so great that in fact the worldwide human population becomes a kind of potential new host for this epidemic cholera. So epidemiological historians now locate the beginning of modern cholera, global cholera, in Bengal in 1816, the year after Tambora, the first global epidemic. We're currently in the 7th, but the first epidemic dates from 1816, 1817, and can be directly linked back to Tambora. The global death toll from this cholera in the 19th century runs in the tens of millions. So It's impossible to imagine the global 19th century as it was without cholera. It really shaped societies, it shaped our modern global health institutions, it shaped modern governance in so many ways. It's extraordinarily central to the history of the 19th century. And the argument I make in the book, which is, I think we fall short of proof. Proof is beyond us, but there's a very, very strong circumstantial evidence linking the eruption of Tambora to the evolution of cholera in 1816.
That's fascinating. In the chapter on China, you talk. There's a link between Tambora, and I've got to mention, by the way, for those, I urge people to sort of get this book. There's some great images in the book. The one of Tambora itself, present-day Tambora, this huge mountain with this big trough, this caldera in the middle of it. You talk about this, about a mile of the mountain got blown apart by this. See, it's the size of the eruption was massive. The effects of the eruption couldn't be seen until later in ways like this cholera epidemic. In the chapter on China, you make the link between this eruption and a few years later, sort of opium trade.
Yeah.
How does that work?
I took for my inspiration a model of causation that climate scientists use. They talk to try to understand the ways in which the climate system and extreme weather patterns develop across the globe. The word they use is teleconnection, which translated means a remote relation between cause and effect. I mean, if we think about El Nino patterns and how, well, in California, for instance, they're hoping that the El Nino that is developing this year will bring a break to the drought, will bring a lot of rain. It should do that. And so those impacts in California begin off the west coast of Latin America, because it's the warming of the seas, a warming of the ocean on the west coast of Latin America that is the generator of El Nino. Also has big impacts on weather systems in Australia, for instance, where I'm from. So it has global impacts. And the only way of thinking about this, one needs to think transhemispherically, and in the ways in which these events, these alterations in the climate system work according to a time lag and over great distances. So this was the model for the book. That the Tambora is a massive geological perturbation that affects the climate system over a span of years, in this case 3 to 4 years, but over vast territory. I mean, the impact is large enough to affect the entire system. You have a volcanic envelope around the entire globe. Right. So in the specific case of China, I've talked about the disruption to the disease ecology of the Bay of Bengal, but the two narratives that I follow mostly follow along two lines. That is disease, the change in disease vectors, and particularly the vulnerability of human communities across the globe to disease and epidemical disease in this period. And the other one is global food shortages. So the disruption to crops and to the shortening of growing seasons across the world. So the China example is a terrific one, where the effects were particularly deadly. You have a community mostly dependent on a rice crop, and you have and rice is an extremely hardy crop. I mean, it is the staple crop for more than 50% of the globe's population. I mean, it's a great crop, but it has one Achilles heel, and that is cold temperatures in the summertime.
Okay.
And that's exactly what Tambora delivers, not for just 1 year. And
Right.
China, of course, has its much vaunted granary system dating back millennia, so precisely to protect against bad seasons. But the thing about climate change of this kind is that it goes beyond the normal parameters of weather deterioration, and so you have 6 or 7 growing seasons, 3 or 4 years of crop yields that are 20 or 25% of the normal, and some seasons where almost nothing is grown at all. So you have very soon you have the population is starving. You have emergency famine conditions, and this was what was happening across the entire prosperous province of Yunnan. You have slave markets for children opening up. You have infanticide. You have corpses by the road. You have a human emergency of the most drastic proportions. And it's in the aftermath of that terrible period of the late 18 teens in China that you begin to see Yunnanese farmers converting their crops from rice to opium, because opium is a much more reliable cash crop. So their reasoning is that in future times of famine, they will be able to raise money in order to buy grain, in order to buy rice for their families on the market, which is precisely what they lacked during the Tambora emergency. They couldn't grow rice of their own, nor could they buy it on the market where prices were sky high. And so there was a almost instant transfer of arable land over to opium, which turned out to be a much more reliable crop for them. And now here we are 200 years later, and that area has been for decades now the center of global opium production. It's the so-called Golden Triangle.
Right. Interesting legacy
Yes.
of one eruption 200 years ago.
Yes.
One of the chapters in the book tells a really interesting story about the United States and about the effects of this eruption on climate, on weather for 3 years in the U.S. And you talk about this great debate over weather between Comte de Buffon, the French scientist, and Thomas Jefferson. There's a line, actually, in the book, which is very striking for present-day circumstances. You say that following Jefferson's legacy, to suggest that the American climate is bad or getting worse is, in a historical sense, unpatriotic. Can you explain the context of that remark in terms of what happened, what Tambora did to the climate and what it did to Jefferson's own philosophy about the climate?
Yeah, I think we have to go back to the 17th century and to the colonial and the pre-revolutionary and colonial period, where there is a strain of anti-colonial sentiment in Europe, sustained by writers such as William Robinson in his multi-volume History of America, which is very influential, and by the Comte de Buffon, where their thesis about the North America was that it was essentially uncongenial to both human and animal populations because it was too cold. The winters were too severe. And Buffon wrote about how his theory of degeneration from old world to new, that even species, including humans, transported from the old world context to the new world, would necessarily degenerate. And of course, this is not a positive message. Clearly, this is a meme which needs to be pushed back against by the intellectuals and politicians in the United States. And so the ultimate intellectual politician, Thomas Jefferson, spends a great deal of time pushing back against this anti-colonial theory of climate pessimism that surrounds the United States. And you have, the encouragement for migration and attempt to build up the US population. It's not good to have a theory, a degenerative theory of American climate out there as in popular belief. So climate optimism is a very important part of the work of early American intellectuals and scientists and politicians. And this is why in only a few years before the eruption of Tambora, you have an acolyte of Thomas Jefferson in Vermont, writing a history of Vermont, in which he talks about how the clearing of the forests and the bringing of the land under the plough has ameliorated the climate, has ushered in warmer winds and better weather and a more congenial climate, and will probably increase the average annual temperature by 10 degrees Fahrenheit. And in the book, I actually I allow myself a little exclamation point in parentheses after that, a particular projection that North America would warm by 10 degrees. And then, of course, he says this at the outset of the coldest decade in American history. So you have this tradition of climate optimism coming up against the Tambora event, and the late 18 teens, which are the coldest years in American history. And that as a kind of a terrible shock, a psychological shock, and a collective national trauma. You have entire villages, in Vermont and New Hampshire packing up and heading west. It's the first major demographic shift from the East Coast to the West. Joseph Smith's family, they leave Vermont and head to New York State. It's part of this movement to the West because people were starving, were afraid of starvation conditions. They felt that perhaps the Comte de Buffon was right after all. And you have the shortest growing seasons on record all through New Hampshire, Massachusetts, New York. So it's a real shock to the system. And it's not taught in our schools. It's not really in the history books how important the late 18 teens were as a sort of recalibration of American ideals vis-a-vis climate and agriculture. And Thomas Jefferson down in Monticello is writing about, I don't know what I'm going to do if the seasons continue to be so uncongenial to our agriculture. And he ends up losing Monticello. He was already in debt, but the Tambora years are the last straw for him.
Right.
And he describes the westward migration in these years as an avalanche. Those are his words. Of course, the twist in the tale for this story is that there is a massive boom for the frontier west, what is now the Midwest, Illinois, Ohio, Pennsylvania. You have 6 times the amount of grain being shipped down the Mississippi to New Orleans to be shipped to the Atlantic seaboard and to Europe in the years after 1815. So you have a boom, a huge land investment. And then in 1819, when the global weather systems return to normal and the grain-growing regions of the Atlantic seaboard and Western Europe and Eastern Europe come back online, then, of course, logic tells you that the bottom falls out of commodity prices. Right. Grain prices return to normal, and everybody who's invested in the Midwest loses their shirts. So you have the first Great American Depression, which is known to historians as the Panic of 1819. Right. And so we can connect the Panic of 1819, an economic event, again, by virtue of teleconnection. Right. You make the sequence and you bring it back again to the eruption of Tambora.
That's right.
It certainly wouldn't have occurred without Tambora.
That's fascinating. We have maybe 2 minutes left. Briefly, people, I think, may not have heard of Tambora, but they have many people have read romantic literature that was indirectly affected by Tambora. I'm thinking about Frankenstein, for example. You make that connection in the book. Briefly, for those out there who love novels, that novel, another romantic text like this, how did Tambora create the conditions, really, for imagining a text like Frankenstein?
Yeah, well, Mary Shelley, when she was 18 years old, and as I explained it to my own students, there are a bunch of college-age kids on a European vacation, hoping to spend their summer by Lake Geneva, boating on the lake and having lovely picnics, but instead were forced inside by the coldest summer in Geneva's history and by lashing storms and extreme weather. And that's Tambora weather. And because they didn't have the internet and Instagram, they were thrown back on their own resources and decided to initiate a ghost story competition. And Mary Shelley's contribution was Frankenstein. Percy Shelley called it a storm-lashed novel. And if you remember, there are a lot of descriptions of cataclysmic storms and the birth of the monster and such. And the argument or the image that I want to put in the reader's mind in the book is that we need to put the writing of Frankenstein in the context of a humanitarian crisis that was engulfing Europe. You had tens of thousands of people, peasantry in particular, leaving their farms and villages for want of food and taking to the highways and byways of Europe, and going to the market towns, trying to find food. I mean, it was a famine, a subsistence crisis. And if you look at the story of Frankenstein, of the monster in particular, through that lens, he's this kind of benighted, monstrous figure leading, who's a kind of refugee being hounded across Europe. He becomes a kind of figure for the environmental refugee in Europe in those years. I mean, and country after country is being swallowed up by an epidemic of typhus as well. So the idea of a kind of a disease-carrying, starving, potentially violent peasant population of Europe, which is a real threat to the metropolitan centres of Europe in between 1816 and 1818, becomes embodied in the monster and the threat of the monster and his odious appearance.
Right. It's a fascinating story and pretty strong allegorical implications for present day, sort of migrants here, extreme weather there. It's such a great book. Thank you for writing it, and thanks for sitting down and talking with us today. It's great to have you at BYU.
Oh, thanks so much, Matt. I enjoyed myself. Thank you.
Thank you.